To find an inverse, it doesn't matter what the equation is. To find the inverse, you switch the x and y and solve for y. So my first example is a linear equation. Do you recognize that as good old y equals mx plus b form? So I'm going to switch the x and the y. Instead of 1/2 x, it's going to be 1/2 y. But I'm still going to have the plus 4. So you see it's the same equation except the x and the y's have been switched. No, it is not just a sign change, it's a position change. The x was here, multiplied by the 1/2, added to the 4. Now the y is multiplied by 1/2 and added to 4. And then we need to solve for the y. To solve for this y, what am I going to do with this 4? Subtract 4 from both sides. To solve for y, what am I going to do with a 1/2? To get rid of a fraction, you multiply by the denominator. And if I multiply by 2 on this side, I have to multiply by 2 on that side. Did you see I put the parentheses in there? What does the parentheses mean I need to do? So that's going to be 2x minus 8. That's going to cancel the denominator, so that's going to be 1y. That's going to be equal to y. This equation is the inverse of that equation. The inverse is the opposite. It's the opposite equation. And the function notation that we use to represent an inverse is f with a little -1. This is function notation for an inverse equation. Now, I started out with a linear equation because that's the easiest kind of equation to find the inverse for. You may already be familiar with inverses and you just may not know it's called that. In your science classes, have you ever converted a Fahrenheit degree to a Celsius degree? Y'all probably done that, right? Or you've taken a Celsius degree and changed it into a Fahrenheit. Those are inverses of each other. Fahrenheit to Celsius, Celsius to Fahrenheit. Those are opposites. And that's what these kinds of equations do. They do the opposite operation. How do you find an inverse? You switch the x and y and solve for the y. So let's get a little bit more difficult equation. This is not a linear equation. What kind of equation is this? It is a quadratic because x is squared. So we're going to switch the x and the y, and now the y is going to be squared. Switch the x and the y and solve for the y. To solve for the y, we need to cancel out the -10 over here. How do we cancel out a square? What's the opposite of a square? And when we take a square root, to solve an equation, it's always plus or minus. So the inverse of the function we started out with is plus or minus, x minus 10. Plus or minus the square root of x minus 10. Is that too hard? And what does this little f negative 1 mean? That is the function notation for an inverse. Example number 3. Let's use some more function notation. 2x. The function is f of x equals plus or minus the square root of 2x plus 15. We don't have a y. How do we switch the x or y if we don't have a y? Doesn't this mean the same thing as y? So we take this out and use the y equals notation. Now do we have a y? And now we can switch the x and the y to y plus 15. You've got to have an x and a y to be able to switch the x and the y, so we change it to y equals notation. Okay, now how do we solve it? We can't start off by minusing the 15 because do you see that the 15 is under the radical sign? If it was not, if this 15 was outside of the radical sign, the first thing we would do is subtract the 15. But the 15 is inside the square root sign, so we need to get rid of the square root sign. What's the opposite of a square root? We're going to square both sides. The square and the square root are going to cancel each other out. Now that we don't have a square root sign anymore, we can subtract the 15 from both sides. I'm solving for y. I need to cancel out the 2. When I cancel out the 2, I need to be sure to draw my line all the way across because all of that gets divided by 2. So my inverse function is x squared minus 15 all divided by 2. So even though it looked kind of ugly to begin with, it wasn't that difficult. If you do not have the y equals notation, if you have function notation, you need to change it to y equals notation. Now, I haven't done an inverse yet. I've just changed from function notation to y equals notation. To get an inverse, you have to switch the x and the y and solve for the y. How am I going to solve for y? Well, I don't want that denominator. What do I do to get rid of a denominator? You multiply both sides by the denominator so that the denominator will cancel out. I'm solving for y. Add 2 to both sides. And my inverse is 5x plus 2. But what if I don't have an equation? What if I have a table? 1, 2, 3, 4, 5. So, what do you do for an inverse? What do you do to get an inverse? You switch the x and the y. So, if I'm just doing f of 2, do you remember how to do that? I look at 2 and what goes with it. If I am looking at f of, inverse of 2, what goes with it? If I'm looking at f of 12, do we have an x value of 12? But is there an inverse of 12? Now, a lot of times, people are too lazy. You don't want to write out this whole table. It's pretty easy to do. You just switch the x and the y's. But if you didn't want to take time to actually figure out the table, you can still find the inverse just looking at this table. If I want f of -1, what does that mean? It means inverse. It means switch the x and the y. So instead of looking for the x, I look for the y. And that's just the same thing that I would get if I looked at this table. So if you don't want to physically rewrite the table, you can just look at this table, but inverse switches the x and the y. So if I want an inverse, I would look in the y column and find the x. So if I wanted to find f of inverse of 10, I would look at the y and find the x, or I could look at this column where I physically change it. Do you see that I'm saying you don't actually have to physically write it down and change it? You can just look in the other column. That will get you the same answer. And I'm going to show you a few graphs. I believe this is example number 1. This is a graph of what an inverse looks like. This dotted line is the line y equals x. do you see from the graph that these are reflections over this line y equals x? If I folded it on this line right here, these two lines would match up. Can you tell that from the graph? This is a graph of a parabola. Here is the y equals x line. This is its inverse. So this is what's happening graphically. The inverses are reflections over the y equals x line. Come here.